Hey, welcome to this week where we want to talk about something called capital budgeting, and we want to bring in some concepts that we've worked on. We've talked so far about cash flow budgets, or how much money we might need to run an operation, and then we've also talked about time value of money. Capital budgeting kind of puts all this together. Now in this video, I am going to introduce to you or tell you some terms, and I've got some notes here that I want to use to help me with that. But be an active learner and write down these notes yourself. Also, I have an example for you where I want to show you how this stuff works, and hopefully it'll be something that you can follow along with. Then there are other resources in this week and some homework and assignments, so make sure you take a look at those to complete the week. But I want to first start off with this simple set of concepts here, and then I want to add to it just a little bit. Then I want to show you how it works. All right, let's get started. So right over here, you can see that we have got, I'll put my glasses on to see better. Right over here, you see that we've got this term called capital. And capital is really money. And money is really, one of the ways to describe money is not just cash, it's really assets. So things like the amount of cash that we have on hand, so bank accounts, investment accounts, whatever our business has, the most liquid asset we have is cash. So I need to have a feel for that's capital. But also capital is equipment. So the things that I take with this money and purchase, like equipment or like inventory to run a business, or like land, or like buildings, or like grain silos. Any of those are assets. And the term capital budgeting just has to do with, are these asset purchases over time a good investment? And net cash flow is one of those things that we need to know. We need to know the money. In fact, to do capital budgeting, you really need kind of three things, and they're important to identify and then know. The first one is going to be money itself. So our cash flow budget looks at, okay, we start our business in January or whatever month with this amount of money. These are the ways we're going to bring money in this month. These are the ways we're going to spend money out. When you get to the end of January, maybe you're not bringing any money in January. You're just spending money. So you need to kind of know how much is left. Can that start me in February? And then what happens in February? What happens in March? What happens in April? Each one of those months has ins and outs. So you need to know that first right off. Second thing you need to know is the time estimate. So how long is this going to be? Because if you're talking about an investment that's 3 years, then there's kind of an estimate of what 3 years looks like. If the time flow is a lot longer, like 10 years or 20 years, a lot of times when you get into investment decisions like grain bins or land or farming operations, you're really looking at really long-term investments. So that window needs to be known. What's the time? Then the third part is kind of what is the rate? Now these right here, 1, 2, and 3, these are exactly the same things that we've already talked about with time value of money. So they're the same things, but we're applying them in a very specific example, which is called a capital budget. All right, now the last one I want to talk about is really important, is rate. We talked about that with time value of money, but in capital budgeting, rate is kind of the required rate of return, because we're looking at budgeting out to the future. Is this a good idea or a bad idea? Well, rate is going to tell us that $1 today and $1 in the future aren't the same. So what is that rate? Well, in capital budgeting, and really in any time you talk about a discount rate, what does it represent? How do you come up with that number? Well, there's three things that I would like to outline for you, and I've already gone ahead and listed them here. First of all, rate is important, and the first thing to look at is something called the risk-free rate. A risk-free rate is like putting your money in the bank. You can go there and get it at any time. There's very little risk, if any, if all. And so if you put your money in the bank, the answer today is the monetary policy of our government used to create economic stimulus has kept those rates really low. So when you go into the bank, you can borrow money pretty cheap, but you're not going to make much money on your bank account either. So it's like 0.2%. Basically, it's zero. So right now, the risk-free rate we would almost call zero. Now, the next adjustment that we make is for time. So if you're looking at a capital budget and it's a 3-year or a 5-year window, you're not tying your money up too long. You're going to get in, you're going to get out. It's easy to understand what the window is, the risk, the whole bit. It's just easy to understand. It's really short. But if you're talking about a 15-year or 20-year or even a 10-year window, it starts to get kind of hard to see how that might play out. We have a lot of estimations that we have to make. And so the risk for that is an adjustment that you're probably going to make up. If it's longer, you're not going to make as big of an adjustment if it's shorter. So let's say we're looking at a risk to put in some hay equipment, buy hay equipment, rent the land, buy the equipment, maybe build a barn. We've got some investments that we have to make. So those are a longer term window. So let's say that we look at the rate today. Let me put in the percent factor here. The rate per today is 0 risk-free rate. But if I've got to wait, let's just say 10 years, maybe I decide I really want a 5% return on my money at that window of time. Now, the next adjustment that we make is, what about the risk? What kind of risk do you have here? Well, if I'm buying some hay equipment, and I'm going to use that hay equipment to bale hay. I've got a good lease land. I've got the lease secured. Let's say I've got a 10-year lease on the land. I'm going to improve upon it. I'm going to build a barn on it. And at the end, they'll buy back all of those things, the improvements that I've made for me. So I have a pretty good deal set up. It's not too risky. However, all the equipment I buy is going to back off in value. If I decide to try to get out of this earlier, there's some risk there for me. But it's not as much as maybe I might feel like I should have. So I might come in here and put a 3% rate on that. If you just total these, then this looks like about an 8% required return is what I'm going to call that. And that is the idea with rate. That's our required return, and that's how we get that. We use these 3 factors. So you need to make sure you know what all 3 factors are. All right, now, how do you evaluate time value of, or not evaluate time value money? How do you evaluate a capital budget? So I'm going to talk about 3 ways right here really quickly, and then I want to show you how that works. Well, the first one is called net. In fact, let me back up and do the simplest one first. The first one is called a simple rate of return. And basically what the idea is, as a formula, if you just take across the years that you're looking at, 3 years or 5 years, whatever it is, you just take the average return that you would get across those years. So let's just say every year for 10 years, I think I can earn an average of $10,000 each year. You're going to take that average return and you're going to divide it by your initial investment. And so that is going to be it. So our example, let's just say that we've got a return of $10,000 per year. That's what we're going to get back on this investment. And I have to put in, let's just say $230,000. If you average that out, oops, I've got a space in there. If you average that out, that is 0.0434. And if I hit a percent on that, give it a few decimal places, that's an average return of 4.35%. Well, that's what on average I would return by taking the average and dividing it by whatever I have to invest to get that done. If I'm looking at, again, my example, if I'm looking at $10,000, which is what that is, each year, and I have to put in $230,000 to get it, the average is going to be 4.35%. That's called simple rate of return. Now, what's nice about that is it's simple. That's about it. It's not very useful because it doesn't factor in how long that I'm looking at. It doesn't say $10,000 is the average return. Is that the average for a 2-year investment or a 50-year investment? I need to know that. That kind of makes a difference here. So simple rate of return is really easy to calculate, but it doesn't really help adjust for time and risk, so it doesn't do me as much good. But it's a formula that gets used, and it's sometimes called capital budgeting, but not very useful in lots of ways. Another one is called payback period. Payback period is how long does it take to get your initial investment back. Sometimes people like to say, well, you know what, I'm interested in doing this, but how long is it going to take me to get my money back? Now, that doesn't tell you anything about profit. It just tells you about how long it's going to take you to get your money back. For some people, that might help them understand a little bit of the time here and the risk, but it doesn't weigh in rate at all. It just looks at time. So it's got some value here, but it's not as good as we need. The best way is called net present value. I'm going to abbreviate that. And internal rate of return. These are really, I should probably say here, these are time value money concepts. They account for all we need. They account for time, plus they account for risk, which really is the rate. And so those are the things that it accounts for, and that is what we want to focus on. All right, so that's enough of the notes and the terms. Let's go look at an example. And I'm going to work through this quickly, but you can follow along later on, play the video. Okay, so I changed this up a bit. I'm looking at a 10-year window of time. I'm looking at an investment cost of $230,000 from UHAY Equipment, building of a barn and some other things to get me going. I've got a lease on the land, so I'm not really looking at a ton of money here, but I am looking at a significant amount of money. I look at the risk return I want, and I've come up with 12%. So I've taken the risk-free rate, time, and then risk, and plug that all together. And I'm saying, you know what, if this can earn me 12%, I might do this. Let's take a look at what it might look like. So I came in here and looked at it today at time value 0. I set a table up. I have time all the way down to 10 years. Net cash flow, separate thing. I've already done that. And I start off today needing $230,000 from that cash flow effort. And each year I'm going to bring back these net values. So that's $45,000 extra dollars that I'm going to bring in. Now, I've got those three things that I told you about. Present value is the best one. Payback period's another idea, and simple rate of return is one of the least valuable ones. Little formulas are up here telling me what to do. Let's go and find out that. So the simple rate of return is going to be basically just an average. So I say equals average. So over the 10-year period, that's the average I'm going to get. So there's my average. What did I have to spend in my investment? I'm going to put a little negative in front of here to get that. Well, I don't have to do that. It's right up top. So there's how much money I had to put in. And so if you do a simple rate of return, then the value is just equal to the average return is that. That's how much money I had to put in. So if I come over here and go double here, interest here, 16.59%. So if you're looking at this and saying, man, my investment only needs 12, simple rate of return looks pretty good. However, remember, this one does not account for time or risk, so I'm going to kind of just ignore it, but that's sometimes calculated, so that's there. All right, payback period. How long does it take me to get my money back? Well, I'm going to write a little formula that just says I started out with being short $230,000 because I had to pay that out. But in year one, that $230,000 is what I had to pay, but I get $40,000 back in year one. So actually I'm only out $185,000. Now I've written that formula in such a way that I can just copy it down. And as long as it keeps being negative, oh, there we go. So in this last year, that's positive. I'm getting extra money back. But in year, in year 5, right over here, in year 5, I am going to be short. In year 5, after I get done with year 5, I'm still short by $6,000. So I'm going to do a little formula here. And so year 5, I'm going to go ahead and actually put a little negative in front of it because I am already short. It's already a negative. I am short $6,000, and in year 6, I get $36,800 back. So 6,000 of that 36,800 is what I'm missing. That is 0.16 of that year. Take that dollar sign off of there because that's what that is. So it looks like to me that I've got to go a full 5 years. I get into the 6th year, and so that's going to be 6.16 years is how long it takes me to get that money back. Because I got to go all the way through year 1, still short, all the way through 2, short, all the way through 3, still short, all the way through 4, still short, all the way through 5, still short. 46,000, I bring 40 in that year, still short. Going to year 6, I don't need it all. In year 6, I need about 0.16 of that. So 6.16 years. That's how long it takes you to get your money back. Still doesn't tell me about the risk. That's the value of net present value. All right, how does this work? I'm going to show you 2 ways to calculate it. First way is it's looking at what are the dollars at today's value. That's the concept of present value. So equal sign. Today, I'm out $230,000. Pretty easy. In year 1, I get back $45,000, but I got to wait 1 year to do that, and the rate's 12%. So here's where we do equals present value, and we start calculating this. What's the rate? That rate is right there, comma. What's the time period in? Well, it's 1, so I go ahead and grab that with a comma. And then the other is what's the future value? Well, it's $45,000. Now, remember with time value of money, when you do this, present value and future value conflict with each other. So I need a negative on one end of this so that my answer comes back positive. So I'm going to place that negative out there on that future value. To keep it simple for me, I am going to close the parentheses. So that 45,000, if you got to wait 1 year, is really more like 40,000 in today's money. Now that I've written that formula, I'm going to lock a few of these. I want the interest rate to stay right there. So I put a dollar sign in front of the 6 so it doesn't come to 7 and an 8 and a 9. The A1 is the time I want it to move, and the dollars is D11. I want it to move. So now I can just simply copy that all the way down. All right, so it looks like here that we're going to go through these and see what's going on here. I did something wrong. If I do this, that's 45,000 across 2 years, and that 48,000, that's really discounting that. And it says 81. What am I doing here? It is present value. That's the rate, still 12%. That's 2 years. D12. Let's see here. Let me click the f of x function. Over here it kind of tells you, oh, it's a payment. Yeah, I kind of messed up where that went. Let's go back and fix that. Be careful when you're writing these formulas. Hitting f of x is actually a really good idea. It brings up this builder, and that way you can see exactly what those are. That shouldn't have been a payment. That worked with 1 year. It ought to be a future value. That's what that was. Now hit enter. And we're going to get, or hit done, I guess. So I've got it, get the same number, but then when I bring it across all of these, there we go, it kind of helps me. So I'm looking at that 45,000 is really like 40. 48 is really like 38 because you got to wait 2 years. Jump down here to 24,000 is really like 96. 15,000 is not worth much. Last year, here's what happens. We get very little money back in our business, but we sell all this equipment back after 10 years to the landowner. They pay us a little bit back for the improvements we made and what they're worth 10 years from now. We decided that's 30,000. So you're really looking at that's really only worth about 15,000. So you got to spend 230,000. You get back all of these values over time, factoring in time and rate. And then if you total the whole thing up, it's really negative. Now that doesn't look good at all to me because that means I've still got some of that money right there that I haven't gotten back when you look at the value today at time value 0. So that's actually a negative net present value. And so this means that we really wouldn't want to do this. So here's what's interesting. Compare this. Looks like almost 6% we get back on our money. This makes it look like it's a good investment. Payback period, the window's 10 years and you get your money back in year 6. So 7, 8, 9, and 10, and most of 6 are all going to be free money. These all look like this could be in a good investment. But time value money really gives you the clearest picture. Net present value does, and this is negative. So really it looks like a bad decision right here. So that's kind of the details of how you would do this. Now you don't have to do this by each year one at a time. I did it to show you the values. Actually, if you come down here and use your formulas equals net present value, that is a calculation right over here that'll do it all in one step for you. So the first thing you do is what's the rate? Well, it's 12%. What are the values? Well, you can't start at time value 0 because that's already known. You don't have to calculate it, but you can start at 1. So our first payment all the way down to our last, and we hit enter here. I got too many NPVs. We hit enter here, but we're not using this 230 yet. So here's what I do. I keep it outside of my parentheses, and I just add the time value today because you don't need to discount it. It's at time value 0 right over there. So now I hit this and you get the same answer you get if you do it one at a time. It's just a lot faster if you do it using this NPV formula. So once again, it's the rate. It's all the year 1 through whatever. That's the case, it's 10 years. And then you add back what you got to pay out up front. And that comes out to be negative and it's a bad investment. And that's what that's showing you. Now there's another term called internal rate of return. And that is going to be another formula. In fact, you can do IRR. Or again, you can just choose from the common financial terms here, and I've got it right there for me. Now it's got even less information. It just says what are the values, and you just simply come up here and say, well, it's that 230 out front, and then every year you get these monies back. And so that averages, not averages, based on time value of money, that calculates the actual earnings. And here's where we get the picture. This thing is only earning 11.69%. You required 12. That's why that's negative. Now, if you look at this whole investment and you said, you know what? It's not as risky as I thought. Maybe it's more like an 8% required return. If you did that, all of a sudden you're like, all right, now my net present value is positive. This thing's still earning 11.69%. You just change what was required. So it really depends on kind of this thing you looked up out front. Of course, the advice is not to change that. If you've calculated your risk-free rate, your time rate, and your risk rate, and that comes up at 12%, then you better start to stick with your data. But anyway, those are the ways that's calculated. Last thing I want to throw at you is this a good decision? And my answer, based on where we have it, actually is no now, because net present value is negative. And that's what that would be. Payback period, we've already got it. Payback is 6.16 years. Simple rate of return is 16.59%. These look pretty good, but this is not a good investment because net present value is negative. All right, what's another way that sometimes businesses go ahead and do it, but they look at it in a different way, and that's going to be that we might look at borrowing. Can borrowing help us? Is money cheap enough? Could that make this worth it? Let's take a look. Now, initially, it's the same rates. We still have the resale. We still have these amount of money. But what I've done is I've gone in here and said, what if we put 20% down? So instead of having to pay $230 up front, I just wrote a quick formula and says, hey, tell me what 20% of that would be. And actually, it's $46,000. Now, I need to come over here and look at then, what does a loan look like? Well, I did have to pay out, right? I had to pay out this $230,000. However, I've already factored in that I'm going to pay that much down, so I'm going to have to borrow $184,000. All right? Now, if I borrow $184,000, I'm going to have to pay interest on that. Let's just say the loan's 6%. I'm not looking for 10 years. I'm looking at 5 years on the equipment to get this going. Need $184,000. I'm only having to pay out now $46,000. I'm going to pay this back over some time period. So let's calculate that. All right, equals payment. You just start typing that, and it pulls up like we've done before. Let's see, the rate is 6%. The time period is 5 years. And the present value, I'm going to put a negative in front of that, is that amount right there. That means every year you would have a loan payment of that. I'm going to press equals each year, and that's going to continue across 5 years if I got all of this right. Interest rate's going to be, well, you started out borrowing that much money, and you got a rate there. Looks like about $11,000 in interest, but your payment was that minus that rate of interest. And that's going to come up with that we must have principal of this then. Now, you got a new loan balance because you got what it used to be, but I'm paying this heavy amount down in principal, so there it is. Interest have some formulas that you don't want to move around on you. One of those is that rate, so I'm going to put $sign to lock that cell, and everything else can move, I think, so I'm going to just bring that straight down, make sure I'm good to go. That is 0. That's what that should be. You pay your loan off. So it looks like this loan amortization is right. That is the right payment. So if I come over here in year 1, actually now year 1 is going to be, the actual net cash flow is going to be, well, we bring back $45,000. However, we got ourselves a new loan here. So actually we only bring back about $19 in money. Now I'm going to continue that on for all of these years, and you're going to get to year 5, and then actually you're going to get back to what we thought we had because the loan's paid off now. Now you can notice here that in year 1 we just have enough money to pay the loan, so we're okay. In year 2, we have enough money to pay the loan, so we're okay. In year 3, we've got enough money to pay the loan. We're still okay. Year 4, we're still okay. Year 5, it looks like it's when our business starts to maybe have a lot of equipment repair and some expenses we're budgeting for. So actually, you're a little bit short here on the loan. Now, the answer is your cash flows will handle this in the beginning. So that's just what you're going to be out. It's not bringing you money back. You're paying money back in this particular example right here. Now, the money now, all of a sudden, we don't have that loan anymore. We're back in good. And so does this help us? Let's just see. Now, I could calculate all of this. I could calculate simple rate of return, but I'm going to ignore all that. I'm interested in net present value equals. Let's go over here and do NPV. So NPV is going to be the rate. Rate's still our risk rate. It's still 12%. The values are going to be this new data table. It's going to be all of these values right here. And remember, we're going to add to that we had to pay out $46,000. Not as much as we used to, but what does that look like? The answer is that actually turns this into a good idea. What about internal rate of return? Same idea. Let's go over here and use our f of x shortcuts. What are the values? Remember, on this one, you do start off at the very beginning. We've paid $46,000 out, but right away in year 1, we get back a little bit less, not as much, but we didn't have to pay out near as much up front. So you grab all those numbers, and it tells you that, hit done, that the internal rate of return is 18.8% now. Now, you may say, hold on, same deal, same cash flow, nothing really changed. All we did was mess with the borrowing of that money. Well, we borrowed at a rate of 6%. Remember, your business is earning 11.69. Now, we require 12, so by itself, it's no good. But if you can borrow that money at a cheaper rate than you're actually earning, then it's going to actually raise the net present value, which it did. And it's also going to raise the internal rate of return. So now, is this a good decision or not? The answer is now, yes. If you borrow, it works because net present value is what? Positive. Let's ignore payback period for now. And so basically, that's what I wanted to focus on is how does this look when you borrow? All right, hopefully this helps you see the concept of capital budgeting and a very specific example without any borrowing or with borrowing. And that is sometimes how you see in businesses where they're like, you know what, my investment's going to earn me some money. However, it doesn't earn me what I really want, but I can borrow that money. And if that rate is cheaper than what I'm actually earning, that's why a lot of businesses borrow. When they do that, that can turn an investment that really wasn't a good idea on its own, using its own money. But if I can borrow that money at a lot cheaper rate, I might as well put it in here and that will actually earn me money. So hopefully it kind of gives you an example of capital budgeting and how sometimes borrowing can help that out. Take a look at this, write the notes out, take a look at the examples I have for you this week and the homework, so see if you can do the work yourself. All right, thanks a lot. Let me know how I can help.